I have made my own underwater drone, participated as a mechanical engineer in a world-class underwater robotics student team, and worked for a multi-billion-dollar subsea company. If there's one thing I know, it's how to make electronics waterproof. In this video, I will not only show you one method to do it, but I'll try to give a complete overview of all the most common methods, as long as telling the pros and cons, so you can find the best method for your project. I have divided this video into two parts. First, we will be looking at permanent methods, where you somehow coat or cover the electronics. Then we will be looking at how you can make your electronics waterproof in a non-permanent way by making an L-house, and I will show you how you can do this. Welcome to the ultimate guide for waterproofing electronics. Perhaps the simplest way to waterproof electronics is to use a waterproofing spray. For example, this one sold by Flywoo. These are sprays that contain small hydrophobic particles, meaning that once you have sprayed the part, it will repel water and droplets will just slide off. This can work great to make something resistant to rain and is therefore often used in things like FPV drones. Another benefit is that the coating is just a really thin layer, so you can modify or change the electronics without taking the coating off. However, this method will not make electronics completely waterproof and should therefore not be used for parts that are going to be submerged in water. If you do that, your parts will break. A more robust method is coating the electronics. This can be done easily by a nail polish. In this clip, I am using a colored nail polish because it makes it easier to see what parts are already covered and not, but you can also use a clear one for a cleaner look. Another option when coating is to use something called liquid tape. This works just like nail polish, but instead of forming a hard layer, you get a flexible rubber-like layer. This is great if you need to waterproof parts that might bend, like exposed parts of a cable. Just as a little side note, the liquid tape I used in this clip was very out of date and very bad. Usually if you buy a new one, it should be more smooth than the one I'm using here. So, the main benefits of nail polish is that it dries very quickly and it's not dangerous to get on your skin, while the main benefit of liquid tape is that it forms a flexible layer instead of a hard one. The benefits of coating is that it's very light and takes up almost no space. Therefore, this method is usually preferred for making light and small things like flying drones completely waterproof. And it has been used to make flying drones that can even go underwater, which is pretty cool. There are, however, two main drawbacks to this method. The first is that once the electronics are coated, they are not modifiable. This makes it very unsuitable for anything other than finished PCBs. It also requires you to be extremely thorough when you apply the coating, because if you miss a spot, that could completely destroy your electronics. The third permanent method is to completely cover the electronics with something known as a putting compound. This is similar to the coating method, but instead of just covering the surface of the electronics, you completely surround it with a liquid that will harden. This is most easily done by making a 3D printed mold where you put the electronics and then filling this mold with the putting compound. As you can see on this video, the mold I made also has small holders to make sure the epoxy can go underneath the PCB as well. For smaller pours, using something like liquid tape can work really well. However, for bigger pours, using epoxy has the benefit of being really hard and also usually pretty cheap. When it comes to what epoxy to buy, it is very important that you buy an epoxy made for so-called deep pour and not an epoxy that is designed for making glass fiber or carbon fiber parts, such as the ones from West Systems. Trust me, I've done this mistake before. I also have bad experience with ordering from brands like AliExpress, but a very good brand I found is called Epodex. A link to their website is in the video description. One thing to watch out for when using epoxy is that the hardening reaction of the epoxy can generate a lot of heat. So if you are applying a lot of epoxy in one go, you might have to do it in layers. The benefits of using a putting compound is that it's very reliable and completely foolproof. No water will get into those parts, no matter what the pressure is. The downsides are that it takes quite a bit of space, is really heavy, and it's also really permanent. Once you have covered the electronics with this method, there is absolutely no going back, and fixing or repairing the electronics is no option. Potting compounds can also be used to make things you buy waterproof. For example, in this video I am filling a small flashlight with epoxy, and this works great for most things where you can just open them, fill the insides with epoxy, and then they will be completely watertight. All the methods I've shown so far have been permanent in some way, making it impossible to modify, change or fix the electronics. If you don't want to cover your electronics permanently, you will need what is commonly referred to as an L-house, or electronic housing. This is basically just a waterproof container where you can put your electronics and keep them safe from water. I will now show you different ways to make an L-house, divided into 3 steps. First, we will look at how to make the L-house itself using 3D printing or other materials. Then at how to make the opening of the L-house, so it can be opened and closed while remaining waterproof. At last, we will look at what you can do if you want cables to go in and out of the L-house, because this is harder than it might seem. So, how can we make the L-house itself? Probably the most available method today is 3D printing. However, even though they might look like it, most 3D prints are not waterproof. This is because there will always be microscopic gaps in 3D printed parts between the layers. However, there are 4 strategies that we can use to make 3D printed parts more waterproof. The first strategy is smart design. The microscopic gaps in 3D printed parts mostly form at top surfaces or intricate geometries. That means that if you design the L-house with a very simple geometry, and so that all the parts in contact with water are either sidewalls or bottom layers, it will hold up a lot better. I use this principle to create this part and let it sit underwater for 24 hours, and it will still completely dry on the inside. Still, this method should not be trusted for critical applications or for high pressures. The next strategy is to enable over-extrusion on your 3D printer. This makes the printer extrude out more filament than what is actually needed, which helps fill in the small gaps. However, it is not the most reliable method, will decrease the quality of your 3D prints a lot, and will increase the chance of the prints failing. On Bambolab, you can enable over-extrusion by going to calibration, flow rate, and then clicking manual calibration. Another way of making 3D printed L-houses waterproof is to coat them with, well, something. This works just like coating your electronics. You just apply a layer of some sort of coating, and this will cover all the microscopic gaps. I usually use nail polish just because it's cheap and widely available, but any sort of waterproof painting should work. The last way of waterproofing 3D prints I will show you is to treat the 3D printed parts with something called Dichtol. Dichtol is a substance that is designed to fuse layers of 3D prints together. To use it, you can either dip your part in Dichtol, or you can pencil it on the part using a brush. This is what I'm currently doing for the buoyancy tanks of my underwater drone, and it works really well. If you use one or multiple of the techniques above, it is absolutely possible to make a waterproof 3D printed L-house, at least if it doesn't have to withstand high pressures. But many of the methods are pretty unreliable and require quite a bit of manual work. Therefore, it's often preferred to just buy waterproof materials instead and skip the 3D printing. Here are some popular options. Acrylic pipes are really cheap and widely available. For my underwater drone, I'm using a 250mm long acrylic pipe, which cost me about $18. For things like underwater drones, it is really common to use this in combination with end caps that are either machined or 3D printed and filled with epoxy. It is also pretty common to make L-houses out of aluminium. These can come in a variety of shapes. This is kind of the upgraded version of acrylic pipes, because aluminium is a lot stronger and can handle a lot more pressure, but it's also usually quite a bit more expensive. The last option I'll mention is to machine a L-house from some sort of solid plastic. This is a middle ground between acrylic pipes and aluminium. It's cheaper than aluminium while still being reliably waterproof and flexible in terms of shape. This camera housing was, for example, made by machining a type of plastic called PUM. Today it is very easy to get your own machine parts via sites like Protolabs. You can just upload your 3D model, select the material, and they will make the part and send it to you. This is, however, quite expensive compared to 3D printing, so you have to make a tough decision there. If you want to be able to open and close the L house, you need a way to make the opening watertight. If you have two parts that go together, even if it feels really tight, there will always be a gap where water can leak in, especially at high pressures. To stop water from leaking in, you need something flexible that can fill this gap. For this, you really only have two options: O-rings and gaskets. O-rings are flexible rings typically made from rubber. The most common way to make an opening using O-rings is to have a cylindrical part with a little groove for the O-ring that is slid into another cylindrical part, like this. The grooves should be designed so that the O-ring is squeezed a little bit together. I've included a very good source explaining a bit more about this in the video description. It is also recommended to apply some sort of grease to the O-ring. If not, fitting the parts together will be really hard and you might break the O-ring. There are special O-ring greases designed just for this purpose, but they are typically really expensive and any sort of grease will do. You can also have O-rings between two surfaces that are pressed together, like shown here. But trust me, the pressure required to compress the O-ring enough in this sort of configuration is probably way more than you think. The only way this is going to work is if you have a lot of screws holding the parts together, like in this configuration showed right here. I mean, just look at how many screws there are. Gaskets are just like O-rings, but instead of being circular, there are pieces of rubber that come in a variety of shapes and sizes. These can be used for parts with complex shapes where an O-ring wouldn't work. Usually when having an L house, you want some sort of cables to go into or out of the L house for example, powering motors or transferring information. There are three main ways we can do this. The first option is just to make a hole, put cables through the hole and seal it with glue. Will it work? Well, yes, technically, but it's a really unreliable way of doing it. Trust me, I've seen multiple projects ruined due to this method failing. A more sophisticated way is to use epoxy. Probably the easiest way of doing this is designing some sort of part where the cables go down through an epoxy filled layer on their way out of the L house, like this part right here. You can see that the cables have to go through all this epoxy to get out of the L house. You can also see that all the wires have a little part with no insulation inside the epoxy. The reason for this is that at high pressures, the pressure will push water through the cables themselves between the copper wires and the insulation. By taking off the insulation inside the epoxy, we avoid this problem and get a solution that also works at high pressures. The even more sophisticated option is to use something called underwater connectors. These are connectors that can be glued or screwed into holes in your L house. Some of them also let you disconnect and connect the cables, which can be really practical. One example are the Predator connectors from Robotics. These provide a great, very professional solution. However, they are quite expensive compared to just using glue or epoxy. With all these parts, you can make an L house that keeps your electronics safe, but also allows them to be waterproofed. If you're watching this video because you're trying to build your own underwater drone, we make kits with all the required components to make one. It's fully customizable. You will get all the basics, so you don't have to spend half a year figuring out things like what motors to buy and how to get them to spin. And you can jump straight to the fun part of making the ROV look and work exactly how you want. More info in the description.